So you've got a chance to try this on your own, okay? And I want to put this into math talk. So this is called the slope formula. A line that passes through points x1, y1, that just means the first point, the x value on the first point, the y value of the first point, and x2, y2, again, these are the values for the second point, has a slope given by the following formula. So the slope equals m, we know that. It's called the rise over the run, all right? This is just sort of a gimmicky way to remind yourselves. Rise means up and down, run means like you're running on a horizontal platform, right? So the top numbers are the y's, that's our vertical, right? And the bottom number is our run, that's our horizontal x, okay? So we're more comfortable, I think, at this point with this delta y, delta x. Remember, delta means change. So the change in y is over the change in x. And so what does that really mean? What do we have to do? We got to do this subtraction. So we take the y value from the second point and we subtract away from it the y value from the first point. That's our top number. And then the bottom number is the subtraction between the second x and the first x. Okay, so let's put this all together again. Let's try exercise 3. So it says, consider the line that passes through -3, 2, and 5, 8. Plot the points and create your guidelines. Let's do that first. So -3, 2. Okay, -3, 2, and 5, 8. So 5, 8. Looks like that. Okay, now it wants us to create our guidelines. So let's do that. Clearly, I'm going up, and then I'm going right. Okay, so what is the difference between the y values? So we're looking at our vertical line. Let's take a look. Okay, how many boxes? 1, 2, 3, 4, 5, and 6. So this looks like a 6. Okay, let's get rid of this quick. This is a 6. Okay, let's make sure that that's the case when we do our subtraction. So let's take a look. The y values, all right? Which ones are the y values? That are the second ones. And again, I'm going to take the second point, and that's going to be my first value for my order when I'm doing subtraction. Remember, order matters in subtraction. So I got 8 minus 2, which also equals 6. So that is correct. Okay, in both regards, my change in the y's is 6, both algebraically and with graphing. Okay, let's try to see what is the difference between the x values. So let's do that. Okay, x values, how many boxes? 1, 2, 3, 4, 5, 6, 7, 8. So that is an 8. Okay, and let's make sure when we do our algebra, it is also 8. So let's look at the x values. Okay, x values are here. So we've got a -3 and a +5. Again, I have to keep the same order. So I'm starting with the second point. Okay, and then I'm subtracting away the first point. Now, I have 2 minuses next to each other, and I don't like that. So I'm putting the -3 in parentheses. Anytime you have 2 operations next to each other, you got to put the number into parentheses. Don't have 2 operations next to each other. That gets really sloppy. All right, if we tried this in our Desmos calculator, let's do that. Okay, so 5 minus -3, that gives us an 8, which is what we wanted, right? So 8 for this, and we know that we have gotten it correct because we tried it on the graph. And so what is the slope of the line connecting these 2 points? Well, remember this number here is our delta y. Okay, so our delta y is 6, and then our delta x is 8. So let's put it all together. So m is equal to, remember, it's the delta y, it's the change of y over the change in x. So we're just going to plug this in. So which one's which? The 6 goes on top, right? I'm going to make that skinnier. This 6 goes in for that delta y, and then this 8 goes in for the delta x. So let's put that together. So we've got a 6 over an 8. Now, these are large numbers, so you should be cautious if you get large numbers in your slope. you more than likely are going to have to reduce. In this case, there is some reducing that needs to happen. Now, I'm going to show you how you can do that in the calculator and make sure you can get it correct every time. So let's say I don't know whether this is reducible or not. I'm going to try it in my calculator and see what happens. So 6/8. Remember, the fraction bar means divide. So I'm going to do 6 divided by 8. What do I get? I get a decimal. Now remember this little button here, convert to fraction. We like to use that towards the beginning of the year. We're going to use that again. And what have I found? I found the reduced form for me. So I didn't even have to know what I needed to reduce the numerator and denominator by. I didn't even know whether it could happen or not. I just have to put it in the calculator, convert to fraction. If it comes out as a different fraction, that means it needed to be reduced to that. So 3/4 is my slope here. So equals 3/4. So that is my slope. Okay, I can rewrite it here so it's nice and neat. M is 3/4. Now, what does that tell me? That tells me that I can go up 3 and write 4 and find another point. Up 3 and write 4. They're telling me that is a point on this line. Okay, well, let's connect and make sure that that's the case. If I did my line, yep, it goes right through it. Okay, so again, we like to have slope as reduced as possible because what that does is it finds all the points. If I only used the slope of 6/8, I would have never found this point right here. And then if I'd made my line, it might have been a little sloppy. We like to have as many points as we possibly can. It's going to make our line as nice as it could possibly be. So we should be able to calculate the slope of a given line given any 2 points that lie on that line. So let's get some practice on this essential skill. You guys need to be careful of your positive and negative values. So in this one, we had to be very careful about this -3. Okay, this isn't 5 minus 3. That would give us a 2. It's 5 minus -3, which we checked in our calculator was actually +8. Okay, so you guys be careful on this next one, and good luck. I'll see you in the next video.